So here's a little summary of the things we've been thinking about. We've been saying this, it's going to look a little different, but if k is a 0, then I always say x minus k, as you've noticed. If I say it's 2, then I say it's x minus 2. And we can also call x a solution instead of a 0. Some old books used to call it a root. There's a little distinction there that maybe needs to be made, but if x is a real number, then it's the place where it hits the x. Did I say x? If k is a real number, k is where it hits the x-axis. Okay? So, just a little review there of things we knew already. And this is how we're going to do it. We're going to say, well, if x plus 3 is a factor, then I'm going to go put a dot at negative 3. And if x minus 2 is a factor, then I'm going to put a dot at plus 2. Okay? I'm also going to think about the fact that I have x times x squared, because this is x squared, and that's x to the third, and it's positive, so I know it's going to start low, and it's going to do something and go high, okay? So it's an odd exponent, so I know it's going somewhere, and it's positive, because it doesn't say negative, and so therefore it starts down here, and it's going up, okay? So I know that, and then I'm kind of curious about what happens in between. Now, let me mention one more thing. I have this x minus 2 squared, so I know it's not going through. I know it's not going through at 2. It's going to touch 2 and go the other way. It's going to touch it or kiss the x-axis right there, because it's squared. It's an even exponent. All right, now I'm kind of curious. About what happens in between here. I'm curious what happens in between negative 3 and 2. So I'm going to plug in some numbers in between. Negative 2, negative 1, 0, 1. I might not be that curious to put in 4 points, but they were for this example. And then we're kind of curious about where it goes afterwards, I suppose. So they put in a 3 after the 2 to see what was going on over here. And then we can kind of flesh out the graph. I mean, we knew it was going to do this kind of business. We just didn't know exactly. So that's it. We connect the dots. We keep this in mind. I was referring to this. As x gets really small, so does the graph. Well, I said it backwards. As x gets really small, so does the graph. As x gets really big, so does the graph. Okay? As we go out, the graph goes way up. Okay? So anyway, let's graph this function. Well, okay, I know some things. So let's go ahead and plot these things. I know that that's probably not the best. Let me try this again. Try it over here like this. I know that at x is equal to minus 8. We'll call that right here, x minus 8. And x minus 4, so I'm trying to put it right in the middle, about right there. And also at plus 1, so about right there. What else do I know? 1, 2, 3 x's, okay, that gives me x to the third. So I'm going to say x to the third, and it's positive, right? So it's starting low. It's going to do some wiggling, obviously, because I have these 3 places where it hits, and then it's going to take off to one degree or another. Maybe not that much because it's 1 over 12, but it's still going to take off. Okay, so that's what I'm expecting. So let's fill in the blanks. We'll say when x is equal to well, I'm kind of curious about how curious am I? Let's say negative 6. I'm curious about what happens at negative 6, because that would be right in between here. I'd like to know what's going on. And then let's say I'm also curious about negative 1. I'm curious about that. And maybe I'm curious also about 2. Okay, I don't want to overdo it, but I said y, but I really mean that's really h of x, but it's y. Okay. So what happens? Well, let's see. I'll go ahead and say I'm putting in negative 6, so that's negative 2, and positive 2, that's negative 4, times a negative 7, so that's positive 28. 28 over 12. 28 over 12, and it's positive, because I had a negative and a negative. Okay, well, what is that? That's like 2 and... Where's my calculator? Let's see what that is. 28 over 12, 2 and a third. Am I going to be able to tell that accurately on my graph? Probably not. Well, we'll say it's about like that. It is positive, so that's nice to know. And then what happens when I put in negative 1? Well, let's see. That's going to give me 3, and this is going to give me 7, right? And this is going to give me negative 2. So I'm going to say negative 42. Wow, that's way down there. Okay. So we're going to just call this negative 42 down here. Okay? Negative 42. That's way down. And then what happens at 2? I have a feeling this is also going to be kind of crazy. So at 2, this would give me 6. At 2, this would give me 10. And at 2, this would give me 1. So yeah, 60. I can't draw that. That's way up there. We'll just say it's way up there. Okay, so we're going to graph this now. And we know we're coming from down here. And we're going to say it's something like that. That's just terrible. I'll stop at the turning point and connect that. Now I know I'm going way down. I'm probably going down further than that and coming back, you know. There's a turning point I probably missed in there that's further down. And then I'm going on up to 60, you know. That's not so pretty, but I'm not looking for pretty here. I'm just looking for functional. And this is what's going on. Okay, so did we do a great job? No. Do we know where the turning points are? Well, we'll get to that later, but right now we're happy just to have roughly what's going on, and we'll be satisfied with that for now.